not least, record. All right, so in this evening session, we're going to cover the following topics around probability. You're going to look at an introduction to the terms used in probability, look at a couple of laws of probability, and then we're going to work around some problems involving probability. And lastly, which is like a precursor to what we'll do next week, is look at binomial expansion by Pascal's triangle. Okay, so that's the plan anyway. So first of all, introduction to the terms involved with probability. Well, first of all, probability itself is the probability of something happening is the likelihood that it will happen. So values of probability will always lie between the values 0 and 1, where 0 represents an absolute impossibility and 1 represents an absolute certainty. Can whoever's got that playing in the background just mute, please? Has a television on or something, not the sound of it. So yeah, so absolute certainty is 1, absolute impossibility is 0. So by example, if we said what's the probability that the length of wire has 0 resistance at 100 degrees C, well, that's an absolute improbability. The probability there would be 0. If we said that a fair 6-sided dice will stop with a 3 upwards, well, that's a 1 in 6 chance, or 0.1667. If we said what's the chance a fair coin will land with a heads up, that's 1/2, or 0.5 probability. The probability that length of copper wire has some resistance at 100 degrees C is an absolute certainty. Okay, now if what's commonly that P is used as the probability that something will happen. Conversely, Q is used for the probability that the same event, so we talk about the same event, will not happen, such that it has to be that P, the probability it will happen, plus Q, the probability that it won't happen, have to add up to 1. So therefore, from that we can say that if that's the case, P plus Q equals 1, P must equal 1 minus Q, or conversely, Q is equal to 1 minus P. So if we know 1/2 of the probability, we can always get the other half because we know the pair of them, P and Q, probability that it will and the probability that it won't happen must add up to 1 for the same event. Yep. Second term is expectation, E. The expectation of an event happening is defined in general terms as the product of the probability P of an event happening and the attempts made, N. So E is equal to P times N. So if we have a probability of obtaining, if we think the probability of obtaining a 3 upwards when rolling a fair dice, so if we roll the dice, what's the probability of getting 3? It is 1/6. The expectation of getting 3 with 4 throws, within 4 throws, so you throw it 4 times, what's the probability of me getting at least 1 3? It is that probability of getting a 3, 1/6, times the 4 attempts, 4 of a 6, which simplifies to 2/3. Yeah. So that's expectation of an event happening with multiple tries. Okay. Everyone happy with that?
Yeah.
Yep. All good.
Yeah.
Yeah. No dissenting voices.
Yeah.
Good.
Yeah.
Right. Now, another term, a dependent event. Dependent event is one in which the probability of an event happening affects the probability of another event happening. For example, if 5 transistors are removed at random from a batch of 100 for test purposes, and the probability of a transistor being faulty, P1, is determined from that. If at some time later, a further 5 transistors are taken randomly from the remaining 95 transistors, probability of a faulty transistor is again calculated P2. The probability P2 differs from P1 since the batch size has changed from 100 to 95 because we took 5 out of the first test. Yeah. So this means that probability P2 is dependent on the probability P1. For this reason, the second random selection is said to be without replacement. So we're taking another sample, but we're taking it without replacement. Okay, so that's the definition of a dependent event. On the other side of the coin, an independent event is one which the probability of event happening does not affect the probability of another event happening. For example, we take our 5 transistors at random from a batch of 100, and we find the probability of a transistor being faulty. Sometime later, the 5 removed resistors are replaced for a further 5 transistors and randomly taken from 100 transistors, and the probability of faulty transistors again calculated P2. The probability P2 equals P1. Since the 5 transistors are replaced between random draws, the second selection is said to be with replacement. So they're independent events because you've replaced them and you've made the sample size back to 100. We're all clear with that?
Yeah.
In essence, you understand that dependent events, the sample size is not made up. Independent events, you make the sample size back up to the same. Okay, someone have a question? I thought someone was asking something then, and I... No? Good. Right. Moving on then. Conditional probability. This is concerned with the probability of, say, event B occurring, given that event A has already taken place. Yeah. So if A and B are independent events, then the fact that event A has already happened will not affect the probability of event B. So that would be the case in our with replacement sample. If A and B are dependent events, then the fact that event A has already happened, we've taken out 5 transistors, we haven't replaced them, so that's going to affect the probability of the second event of taking another 5. Okay, so that's conditional probability and the differences between independent and dependent events. All right, everyone happy?
Could you just hold up a second? I'm just writing some notes down.
All right, Lewis. Right, next slide. Laws of probability. Okay, so first of all, the addition law of probability. Addition law of probability is recognized by the word or joining probabilities. So if we say, what's the probability of A happening or B happening, then that's what we mean by the addition law of probability. So if we calculate or have the probability of event A as PA, then probability of event B is PB, the probability of A or B happening is given by the 2 probabilities added together. Yeah. Provided that the 2 events, A and B, are mutually exclusive, i.e. they cannot both happen. Yeah, so if you think about a dice, the probability of head or the probability of tail, the probability of one or the other is actually one, isn't it? But they're added together, but they're mutually exclusive because you can't get both heads and tails at the same time. Same as you can't get both a 1 and a 2 on a dice. All right, if we have 3 or more exclusive events, then just add the probabilities of all of them together. Yeah, to get the probability of one or the other, or the third, or the fourth, and so on. Is everybody okay with the addition law? When you hear the word or between probabilities, you add them together. Condition being that they are mutually exclusive and cannot both happen at the same time. Yeah?
Yeah.
Secondly, the multiplication law. This is where if we hear the word and between two probabilities. So what's the probability of getting a 3 and a 4 by throwing a dice? Yeah, twice. So if the probability of an event A is PA and the probability of event B is PB, then the probability of event A and B happening is given by PA times B PB. Similarly, if you've got 3 or more, you just multiply them all together. So when you hear the word and between 2 or more probabilities, it means you multiply the probabilities together. Okay? Any questions?
Nope.
Good. So have a go at that then. Determine the probabilities of selecting at random A man, and B a woman from a crowd containing 20 men and 33 women. Probability of a man. We'll call that PM.
Is it 1 minus 20 over 53?
Why 1 minus 20?
That was using the first formula, which was P equals 1 minus Q. Or
Yeah, but to do that, we know that if we have PM as men, that's the probability of a man, and PW is the probability of woman. PM plus PW equals 1. But we don't know either of these at the moment. Yeah. So what we got is we got 20 men in a group of 20 plus 33 people in total. Yeah.
Yeah.
So that's 20 over 53. And if you do that on your calculator, you should get 0.3774. Yeah. So then you've got 2 ways to find PW, probability of being a woman. You can go PW is 33 over 53, which is 0.6226. Or you can go the way you were going there, TJ, where PW is equal to 1 minus the probability of men. Yeah. So that's 1 minus 0.3774. And you
Yeah.
still should get
I got the
0.
same answers, but back to front, basically.
Yeah. All right. Because if you do it this way, calculate one, calculate the other, then there's a check that these two, 0.6626 and 0.3774, must add up to 1, there or thereabouts, depending on any rounding that you've done. Okay. Or you can use the fact that both of these two add up to 1 to find the second value. All right, and there are times when you'd need to use either of those methods, dependent on what you've been given in the first place. All right. Everybody happy with that?
Yeah.
So let's have a look at the second one then. Find the expectation of obtaining a 4 facing upwards, because someone got confused with that in the other group. They thought it meant getting a 4, 5, or a 6. It's a 4 facing upwards in 3 throws. So we're going to throw the dice 3 times. What's the expectation that at least once you'll throw a 4?
It's what you said at the beginning. Obviously, it's a 1 in 6 chance.
Yeah, probability
It's a
is
6.
1 in 6.
Yeah, because there's 6 faces on this, and then you times it by 3 because you're throwing it 3 times.
Yeah, and the expectation is equal to the number of throws times the probability. So you do it 3 times a 6 equals 3/6 equals 0.5.
Yeah.
Or half. Yeah, well done. Everybody else get that?
Yep.
Good. Right. Move on then. Calculate the probabilities of selecting at random. A, the winning horse in a race in which 10 horses are running. And B, the winning horses in both the first and second races if there are 10 horses in each race.
Yeah.
Not quite.
I've got 0.01 for B.
I got 2.
Yeah, I've got that as well.
Okay. A. What you got for A?
Got 0.1.
Yeah, it's 1 over 10. One horse, one chance in 10 equals 0.1. Yeah. B. So that's P for race 1, and that says and the winning horse in race 2. So and means times. P1 times P2. Both of them are probabilities of a tenth. So 1 times 1 on the top is 1. 10 times 10 is 100 on the bottom. It's 100th or 0.01 is the probability.
All right.
When you see that word and in there, it's not an expectation thing, because it's not a second attempt to have the same horse win in the same race. It's a different race, all different horses in it. Yeah. So it's not an expectation thing. It's a one probability and the second one both happening, one after the other. So they're multiplied together. What did you do?
I did 1 over 10 for the first one, and then for B I did 1 over 10 times 1 over 20.
Okay.
I was thinking at the second race, you've only got half the chance of picking the second one in that second race.
Yeah.
That was all. It's just the way that
Well,
I'm thinking.
Yeah, well, the thing is, the double can't come up if you don't get the first one, can it?
No.
So the key point in this problem is this word "and" in here. Probability of getting the winning horse in both the first and the second races. When you see "and" between two probabilities, you need to multiply them together.
Yeah.
If
Yeah,
that
I've
was
done-
said,
Yeah, I've done that. I
if-
just picked.
if-
I've double thinking it's two. Added the two races
Yeah.
together, two horses together.
Yeah.
If that makes
yeah.
Yeah.
If it said, what's the probability of getting winning horses in either the first race or the second race, then you'd add the probabilities together.
Yeah.
Yeah. Okay. So that's that one. We got one more, a little bit kind of related to engineering and about failure. Probability of a component failing in 1 year due to excessive temperature, so we'll call that P little t, is 1/20th. Failing due to excessive vibration, P little v, is 1/25th. And failing due to excessive humidity, P little h, is 1/50. During 1 year period, determine the probabilities that during a 1 year period, the component A fails due to excessive temperature and excessive vibration. Remember what the key words are. And B fails due to excessive vibration or excessive humidity. And C will not fail because of both excessive temperature and excessive humidity. Have a go at that question. You're doing A, and what have you done, Kirsty?
So I've done PT, which is 1/20, times PV, which is
PV.
which is 1/25, and I've times them together because of the and got 2 times 10 to the -3.
That is correct.
That
That's
is right.
correct.
You
Yeah.
need to press Shift Eng button, and then that will convert it to a decimal.
Okay, so I put shift.
Eng, and then that should convert it.
End. Okay, yeah, no, that's wrong because that's now gone 2000 to 10 - 6.
Yeah, if you don't press the shift, so just press the Eng button twice now
Yeah, no,
to
it's
get
not working.
0.002.
Nope. I've now got 2000 times 10 - 6.
Yeah,
Try
that's still the
pressing
right answer.
Eng, I think.
Okay.
Just the way your calculator's set up. But 2 times 10 to the -3 is 0.302.
Okay.
Yeah.
Where's that